Guys, hello class. Exercise 5E. We are just going to finish off what we did last lesson. We had answered, I believe, can I just have the answers for questions C, D, and then we'll start working on E. Given that when the tap, what is V as a function of T? I need it. V equals? 5E, answer? 5C, exercise 5E. Just finishing off part E. Anyone? Last lesson we were doing exercise 5E, rates of change, question 5. We had gone through questions A, B, C, D, and we were up to question E. Now, we know that the formula for volume is 520 minus 2t plus 1 on 20 times t squared. We know that when you turn the tap off, 20 meters cubed of water will flow out of the tap in that time. Let out a total of 300 meters cubed from the tank. How long should the tap be left fully on? Remember, if you decide, yes, I need to turn the tap off now, another 20 meters cubed of water will still come out. So you really just want to be working out how long it takes to let out 280 meters cubed. So we want the time, we need to find time to let out 300 minus 20, which is 280 meters cubed of water from the tank. V is the volume of water let in the tank at any one time. So we need V to be 520 minus defined as the amount of water left in the tank. Then I want the time when V is 520 minus 280, which is 240. Just look at, we need to go back and look at part A. When the tap is fully on, then it releases 2 meters cubed per second. So going back to what we had, we need to let out, I'm not going to use this, we need to let out another 280 meters cubed. Therefore, it'll take 280 divided by 2, which is 140 seconds, which is 2 minutes, 20 seconds, 2 minutes, 20 seconds. Because, then we add the extra, plus the extra 20 seconds when it's turned off, when you turn it off. That's right. Before you start turning it off. Yeah, so it's 2 minute 20. All right, we'll go back. Wait. So we just need to let out 200. You know how we said we need to let out 280, which was 300 minus 20? Because when you turn the tap off, 20 meters cubed is released. We needed to, I looked back at part C and D, but we need to look back at part A, because when the tap is fully on, you let out or you release 2 meters cubed of water per second. So we just need to let out another 280 meters cubed. So therefore, 2 meters cubed gets released per second. 280 divided by 240 seconds. Yeah. If I looked at that other thing, has anyone got a count? What's 20 plus 20 root 15? Just wondering. If I do look at that. 20 plus 20 root 15. That doesn't help. All right. I should be able to work it out that way, but importance of reading it carefully. If I was to use this function V and try and do it like that, this V is not for when the tap's fully turned on. It's for when the tap's being turned off. So that's why that's not applicable, I believe. I think. Okay, question 6. People said that they could do part A. So to find P, they just integrated dP dt, which is integral of negative 2 t plus 1 to the power of. Yep, and it is because you go plus 1. So therefore it's ln. Oh, we've got to fix it up. Yep. Guys, we've got it. That's the same as the integral of. So if you're integrating a fraction, you've got to look for logs. Function of x is t plus 1. F dashed x is 1. So you know how to integrate 1 over t plus 1, but the problem is we don't have that. So how do I make this look like that? I just put a negative 2 out the front. So I'm doing the integral of negative 2, 1 over t plus 1 dt, which is negative 2 ln t plus 1 plus c. That's the integral. So substitute, you know that the initial perfume content is 6.8. So when T is 0, P is 6.8, and you worked out what C was, and you got ln1 0, so C is 6.8. So your formula is P is negative 2 ln T plus 1 plus 6.8. Part B says, how long will it be before the perfume in the ball has run out? Well, do we want when P is 0 then? So we want to find T when P is 0. So 0 is, who needed this question? Did you try P is 0? Because it says, how long will it be before the perfume in the ball has run out? P is how much perfume is in that ball. So when the perfume in the balls run out, there's no more perfume. P is 0. So therefore, 2 ln t plus 1 is 6.8. ln t plus 1 in brackets is 3.4. Take e of both sides. T plus 1 is e to the 3.4. T is e to the 3.4. Take away 1. And whatever you get there. 29 days. So guys, the worst thing with this is interpreting what the question means. It tells us that the velocity is given by dx dt, question 8, which is 250 e to the negative 0.2 t minus 1. It says, what is the initial speed? That's asking you to find v when t is 0. I'm not going to do any more than that. Part B. What is, well, you've got to read what the question's about. A ball is falling through the air. It's going to hit the ground. So at the end, it's going to stop. Wait a sec. Wait. Girls, when the ball hits the ground, the distance above the ground, x is the height above the ground, x is 0. So when the ball falls down and hits the ground, its height above the ground will be 0. So what you want here is, what is its eventual speed? You want to substitute, the only thing you can substitute is x is 0. And then you can find t, but the problem is, girls, you don't have the equation in terms of x. You've got dx dt is, 250 e to the negative 0.2. Yeah, that's what you've got. So girls, when the ball hits the ground, its height above the ground will be 0. X is 0. I only have dx dt is that. So I need to find x by integrating. The height is x. Yeah, x is the height above the ground. So x is, I'm going to keep this constant there, 250. Integrate e to the negative 0.02 t. Is it 1 over? 1 over negative 0.2 e to the negative 0.2 t plus, you're integrating it. Sorry, what's wrong with me? Let me just get to the next page. I'm integrating and writing the integral. Wait a sec. X, I'm integrating and writing the question. X is the integral of this. I better do that first. dt, got it? Sorry, I already started integrating it and put the integral sign there too. So if dx dt is that, x is the integral of that, which is 250. Integrate this, because 250 is the constant. 1 over negative 0.02. It's just 0.2, thank you. E to the negative 0.2 t plus c. Description error, the equation's -1, so it's minus t. All right? Sub. Girls, don't stress. There won't be something like this.
This is only development.
But development is hard in the this from the turnip book. So as t approaches infinity, well, girls, how would you know? That's the graph of y equals e to the x. Therefore, the graph of y equals, see, this is the graph of y equals e to the negative x. As t gets big, as t, x, so that's the graph of y equals e to the x. This is the graph of y equals e to the minus x as t approaches infinity. E to the minus x approaches 0. So therefore this will equal 250. That's 0. Minus t. If that's 0, well, it's 250 t. That's minus 250 t plus c.
Can we just do rate of change formula and substitute?
Maybe.
Wait, but you need to substitute t. The other t.
T gets really big. What is the speed? The dx dt, not the x. So it's just looking at this. As t gets large, that approaches 0. It's 250 times 0 minus 1. 250 times negative 1. See, look, in other words, just all it's asking is when t gets really big here, what is the velocity? This is the velocity. I was working out displacement. I'll show you. You just look at the curve. E to the minus x looks like that. That's y equals e to the minus x. And as this value here gets really big, as this gets big, well, the whole function approaches 0. So this approaches 0. You can just put 100 or something. It doesn't matter. But it's from the curve. As t gets larger, this approaches 0. So it becomes 250 times negative 1, which is negative 250. Therefore, it's 250, the speed, meters per second, downwards. The negative just means down. It's velocity. Velocity's got magnitude and direction. You know what the clue is? Eventual speed. Eventual means after a long period of time. What will the speed of this be? Oh, yeah. If it is initially, your sub t is 0, x is 200. Thank God we've got some information. So we're going to sub t is 0, x is 200. So I was sort of looking for that in the part before, but there was nothing. So therefore, your sub 200 is 250, 1 over negative 0.2 e to the 0 plus c. What's 200 on 250? It's 4/5, which is 0.8. E to the 0 is 1. No, don't do that. And why don't you do what I just did? Why would you never put that 250 down there? That's right, because of the plus c, so leave it. 200 is 250. Isn't this 1? Negative 1. That? What have I done wrong? Well, we put t as 0 plus c. So therefore, it's whatever that is.
Sorry for the interruption. Any students that have library books to be returned,
Times
please
5.
go to the book hire. And the Mac doctor
Is that right?
will be at the book hire as well. Thank you.
If you divide by 0.2, you're dividing by a fifth, which is timesing by 5, but just do that divided by 0.2. Isn't that what you get? 1250? 1250 times 5? So C is 1450. So therefore X is 250. I cannot release this video. Oh my God. Plus T plus 1450. I'm not. Negative cubic, so it looks like that. You've got a double root at 0 and a single root at 3. So the double root bounces off, but you have to have that shape. The other thing is, if you're not sure, substitute something like t is -1, and you will find that you'll get positive there minus negative. You'll get a positive answer up here, and it'll be up here. That's what the curve looks like. Inflections are here. That's it. That's the only inflection. Look, concave up, concave down. Oh, stationary point somewhere there and here. Oh, do they want the stationary point? You've got to differentiate. dm dt. Oh, I did it by curve sketching, but differentiate, you get 6t minus 3t squared. So it's 3t2 minus 3 minus t. T is 0 and 2, stationary points. Then when you do your second derivative, oh, too tired, you get 6 minus 6t. When t is 0, the second derivative is positive. You know how to do this. Min. And when t is 2, you get -6 for the second derivative. M double dash is -6, less than 0, concave down, max. So we've got those. That's at 2. You can't even see it. There. What do they want now? When is the amount of... Is that the sketch of M or... Yeah, that's the sketch of M. So when's the amount of medicine in the bloodstream at a maximum? Time is? Guys, apparently you're only supposed to sketch from 0 to 3. No. 2. That's the graph of M. That's the inflection. No, I'll tell you. Wait. This is the curve. Looks like this and like that. 0, 2, 3. There must be, the inflection must occur at 1. It does. So there's your inflection. This is M, this is T. That's what the curve looks like. The question says, for part B, when is the amount of medicine a maximum? So when is M the greatest? M is the greatest or highest when T is 2. But it says for part C, when is the amount of medicine increasing most rapidly? Look, increasing, the steepest gradient. That's your inflection at 1. And then it's still increasing but at a slower rate, concave down. So M is increasing most rapidly when T is 1. You're looking for the steepest part of the graph. Well, it will be because, look, the gradient here is positive, but that's the steepest positive gradient. Well, yes, because then the gradient's still positive, but it gets flatter. Most rapidly when T is 1. That's a good application question.
How about 13C?
13C. The beginning. You can do 13 and that, but look, you know what? See 13 and 14, that's looking very much like extension, simple harmonic motion type stuff. And we're going to be doing like a week on that sort of stuff. A week.